Now we have the word classical, empirical, and subjective. Those are the type of probability. So subjective will be just an opinion. This is it's called an educated guess. Empirical, it's dealing with frequency, the number of times happening. Classical is the actual probability, which is what we call it is it's like the birth of a baby boy. That's a half. That is classical because that's actually, that's an actual probability of getting a baby boy, which is one half. But if you're trying to guess on the interest rate, so if you notice over here, you're guessing to see if the interest rate will rise 5.5. It depends on the data. It depends on that person, how much he is educated in the stock market or something like that. Therefore, we're going to call this is a subjective because it depends on his opinion. So that would be subjective. Then go back to the definition, review them, see the difference between classical and subjective in specific. Now we go to the next one. The next one it says right here, since we have defined again z-score, what is the z-score for? Oh, this is for a cumulative area. So you have an area under the curve. Over here, area of 0.4286. We need to find this came from where? This came from somewhere over here and something over here. We need to go back to the table to find out. And what do you find out that z is equal to negative 0.1 and then over here 0.8. So it's z is equal negative 0.18. If you're using the calculator, then you will be using second distribution, and then you're going to number 3, and you're inputting all this value in 0.4286. So when you put this value in, it should give you negative 0.1799, which is to round to negative 0.18. So that will be the answer right here. So now we'll move to the next problem. The next problem right here, we have an expected value. That's a very important definition. Usually it's a problem like this on the final. So it says in a raffle, there is 1,000 tickets are sold at $2. Each ticket will randomly selected, and then we'll win a laptop with a value of 1,200. What is the expected value? If a person buy one ticket, so if a person will buy one ticket, then we're going to say if one person buy one ticket, which is how many? 1 out of 1,000, that's a probability. Then the probability that person could win a computer and have a computer is 1,200. But since he has to play the game, then we will take $2 off from the winning prize. Now, the rest of the people, which is the rest of the 1,000, which is 999 people out of 1,000, will end up not playing or not winning the game. So they'll end up whatever they're paying, that's it, it's lost for them. So now to do the calculation, we'll go ahead and say over here we have 1,198, and right here we have minus 1,998, and we actually, this is a plus, but this is a negative because it came from -2. And when you're done, you divide everything by 1,000. Therefore, this is negative 800 divided by 1,000. So the expected value is negative 0.8. Now, the next problem. In the next problem, find the probability. So in the previous problem we did or, now we have a keyword for the word given. We have if one of 881 subjects is randomly selected, find the probability that the person is non-smoker, given it's a woman. So now here's the given, and actually the way we should write this, it will be it's actually the total of the thing after the word given will be usually in the denominator. So over here we're going to put woman, and in the numerator will be the intersection between the non-smoker and the non-smoker and woman. So let's see if we can find out those two from the table. So if we look at the total women first, that will be 433. So I'll come down here, I'll put in the denominator 438. So that's the total number of the women. Now what we're going to do now, we're going to go to the non-smokers. Here's a non-smoker and here's woman. And I want to look at the intersection now between those two. The intersection will be 308. That is the number will be in the numerator. When you take those two numbers and divide, that number will become 0.694, which is right here. Now, we actually going now from the word what's the independent and dependent. If you go back to the formula sheet, there is something on the formula sheet says if the probability of A, you can write it down, probability of A times the probability of B is equal to the probability of A and B, because that is and B, then that's called independent. That's from the formula sheet. Please go back and look at it. Now we'll take what's the probability of A? It's 0.6. What's the probability of B? Is another 0.6. Is that really equal to 0.36? Well, for sure, that is actually 0.6 times 0.6 will equal to 0.36. Therefore, those are independent. If they're not equal, then I'll claim they are dependent.